Okay, today we're going to do linear law. This one is AMath. This is a pretty straightforward topic, as in what I mean by straightforward is not say it's easy. What I'm trying to say is when they come out during the exam, it's pretty much always the same. They always change the number here and there only. Then usually they will come out one short question and one graph question. So it's pretty important to master linear law. So I mentioned that the question 1 and the question 2, okay, are not the kind of typical question that you see during exam. But over here, I just want to explain about how you convert non-linear form to linear form. Okay, so let's see. Let's warm up a bit, as in let's take a look at this A. Okay, when we have y equals to ax cubed minus bx. Okay, the concern is sometimes there's more than one ways to convert them to the linear form. Okay, and if the question say, oh, you got to let's say big y equals to y over x, then your big x is, let's say, x squared, then you will have to follow. But if they do not state which big y and which big x you're supposed to make, then you can decide yourself. So when you decide yourself, what are the rules that you need to follow? Okay, and I always write it in big Y. Straight line in coordinate geometry is y equals to mx plus c. Correct? So in the AMath linear law, I will use big capital letter Y equals to mx plus c. So both my y, x, and the c are all big cap. Okay, is to remind myself that I am still in the so-called this linear law thing. That's the difference. So over here, you can see that this plus c must be a constant. In other words, constant means you cannot have x or y inside. Okay, and then the x, big X, okay, it can have x and or y. What do I mean by that? It means big X can be, let's say, for example, x squared. If I say my big X is just y squared without x, also can. If I want to say my big X is, let's say, xy, also can. So that means, in other words, your big X can have x and or y. Okay, same apply for your big Y. It can also have x and or y inside. So the only thing you need to do is you need to shift until you get one term which is a constant. Then you can decide what is your big Y and big X. Okay, so that's a rule. So let's try out this one. So you can see that all three terms got x and y. Okay, so I need to do something, okay, in order to get one of the term become a constant. So for this one, it's pretty straightforward. I'm going to divide by x throughout. So I will get y over x equals to ax squared minus b. So do you see that one term doesn't have any x and y already? That means I already fulfill the part whereby I can make up the constant out. So in this situation, then I will say, oh, so my big Y is actually y over x. My big X is x squared. My gradient is a. And then my c is minus b. Okay? And I always want students to write this out. Okay? A lot of students are lazy. I don't want to write this thing. But it's very important to write this out. Why? Because a lot of times, the gradient is not so straightforward as it is just, let's say, for this is straightforward. The gradient is just my a. Then the big C is just minus b. Sometimes, in fact, most of the time during exam, your gradient could be like a over b. You know, your C could be like b minus a. You know, it can be mixture. So that's why I want you all to write out. Gradient is in terms of what? Big C is in terms of what? Okay. But of course, this situation is just like that. Okay, so that's only warm up. Let's move on. Let's take a look at B. I have y equals to hx squared plus k over x. So again, all three terms have x and y. So your objective is, they never give me a choice. So I have a few I can decide myself. So I want to make a constant. So a lot of times the method is either you multiply something or you divide something. So for this situation, I can choose to multiply by x, because if I multiply by x, my k over x will become k only, which is a constant. So I'm going to multiply by x throughout. So become xy equals to hx cubed plus k. So you see, plus k doesn't have x and y. So I already fulfill the rule, and I can straight away say, oh, so my big Y is xy, my big X is x cubed, My gradient for this case is h, and my big C for this case is k. Okay, so this is for question D. Okay, let's move to E. Okay, E, let me write out the question here. So it's 1 over y equals to, this is E, 1 over y p over square root x plus q square root x. Okay, then you see, what can I do? Blah, 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 times y. Okay, a lot of students say, oh, okay, maybe I can multiply. This one actually got 2 times square root x. So I'm going to times square root x, because if I times square root x, this one will disappear. Agree or not? I also can divide by square root x, because if I divide by square root x, this one will become a constant. So actually both ways also can. Okay, so let's say I'm going to choose times square root x. So it will become square root x over y equals to p plus qx. Because square root x times x is x, this one multiply become cancel, become p only. So let's just shift it a bit. So it becomes square root x over y equals to qx plus p. So in this case, my big Y is square root x over y. My big X is x. My gradient is q, and my C is p. And we are done. Okay, so that's for part E. Okay, I'm going to minimize. Okay, screenshot if you all need to, because I'm going to erase and show another 2 questions. Okay. Okay, so now I'm going to do part G. So this is y equals to px to the power of n. Okay, every time when you see that, oh, I have a power that is not number, whereby it's alphabet, then you know that you only have one way to go to do it. Either you log or ln both sides. Okay, if there are base 10 involved, you log both sides. If base e is involved, you ln both sides. Okay, for this situation, there's no base 10, there's no base e. So you can either choose log or ln both sides, up to you. So let's say I choose to log both sides. So you will say log both sides. So it becomes log y equals to log pxn. Okay, then take note over here. Common mistake is what? Common mistake is students happily bring down the n. They say that log y is equals to n log px. This is definitely wrong. Why is that so? Because power laws tells me that I can bring the power down. Yes, but this n doesn't belong to the p. You see, it only belongs to the x. Unless I have a bracket here, then yes, you are right to bring down the n to in front. Okay, but currently it doesn't have. So it means that the n only belongs to the x. So in this case, how I'm going to split it? What I need to do is, this means is log y equals to log p plus log xn, because this is p multiplied by xn. So when I split, logarithm is multiply, you split, become plus. So that's why the n only belongs to the this side. So it becomes log y equals to log p plus n log x. You understand? So take note, the n only belongs to the x, doesn't belong to both of them. So then after that, let's shift a bit, it becomes log y equals to n log x plus log p. And we can see that, oh, so my big Y is log Y. My big X is log X. My gradient for this case is n. My big C for this case is log P. A lot of students say, I thought you said that my C cannot be like, it must only be constant. Then how? But you see, log P actually is just number. P in the first place is constant. You understand? The log is just a function. So this one totally doesn't involve any x and y. So actually log p can be c. It's considered a constant. So that's for G. Now let's take a look at H. So H is quite similar to this one. Y equals to 10ax plus b. And you can see, oh, my power got x. Correct? So the only way to bring it down is I know I have to log or ln both sides. So for this case, you cannot choose. Why? Because base 10 is involved. If base 10 is involved, means that you can only log both sides. So I'm going to log both sides. Okay, so it becomes log y equals to log 10ax plus b. Then, okay, this one just one term only, just bring it down. So it becomes log y equals to ax plus b log 10. And log 10 is what? Log 10 is just 1. Okay? So in the end, you get log y equals to ax plus b. Log 10 is 1, so times 1 become this. So actually, it's already in the form. So now my big Y for this case is log Y. My big X for this case is small x. Gradient is A, and my C is just B. Okay, so this is for question 1. This is really warm up. It's just knowing how to change the non-linear form to the linear form. Okay, this one, question 2. Let's take a look at A. It's again quite similar. It's the same thing because you see, as just now I tell you, right? As long as my power got x, I do log and ln both sides. In this situation, neither way. So I'm going to just ln both sides. Just now, previous question one, I log, right? So now ln. So I'm going to ln both sides. So let's say I ln both sides. I will have ln y equals to ln ae minus bx. So same thing, this one I have to split. Okay, the minus bx doesn't belong to the a. So ln y equals to ln a plus ln e minus bx. And then after that, this one power, you bring it down. So it becomes ln y equals to ln a minus bx. And ln e is 1, so I don't have to write. So in the end, I just need to shift a bit. So it becomes ln y equals to minus bx plus ln a. So my big Y for this case is ln y. My big X for this case is small x. My gradient for this case is minus b. My big C for this case is ln a. Okay, again, this one pretty straightforward. Okay, this one should be quite similar. Okay, let me just do C. XA YB equals to E. So again, you see your power got A and B, right? So in order to bring the so-called power down, okay, for this situation, your A and B power is constant. Okay, I can just log along both sides. But base E is involved, so you can only ln both sides. So let's ln both sides. So I have ln XA YB equals to ln E. And ln E is 1. This one, see, this one I'm going to break it up, become ln XA plus ln YB. Bring down, so it become A ln X plus B ln Y equals to 1. Okay, then how are we going to do? It's see, B ln Y equals to minus A ln X plus 1. So a lot of students say, oh, okay, like that can we did ln, but you must take note, the ln Y on the left hand side. Okay, you just think about, let's say when you're drawing a normal straight line graph, you always y equals to, let's say, 2x minus 5. It can be y equals to 2/3 x plus 10. Do you ever see something like 2y equals to blah, blah, blah? No, right? You don't see that 2y. It's always single y. Okay, so make sure that same thing, your big Y, it must be a single y. So you see there's an extra b there. So by right, you're supposed to do one more extra steps by divide by b throughout. So I'm going to divide by b throughout. So it becomes ln y equals to minus a over b ln x plus 1 over b. But not to worry, because 1 or 1 over b, they are still constant because it doesn't contain x and y. So for this case, my big Y is ln y. My big X is ln x. You see my gradient now starts to get more complex. So my gradient for this case is minus a over b. My big C for this case is 1 over b. Okay, so always must write out this information. So this is for this question. Okay, again, screenshot, I need to change the page again. Let's take a look at E. See, it gets more and more complex. So let's say you see, right, x squared plus ab minus x. So be careful on this thing. Students, remember just like I said, oh, you see the power got alphabet, then you go and log along both sides. But you cannot straight away log along both sides now. Why? Because this one is a plus. So just now previously, every time is a multiply, then you straight away log along both sides, correct? But this one cannot. Because if you're going to log it, then all my A and B are stuck together with my log. So in such a situation, what you have to do is, you will have to shift this to the left-hand side. So it becomes 1 over y minus x squared equals to ab minus x. Then now you can log on both sides. You understand? So it becomes, let's say for this case, I'm going to log both sides. So it becomes log 1 over y minus x squared equals to log a b minus x. Power law, bring it down. So this one still remain, nothing changed. This one become b minus x and log a. And this means you can just like that. So it become log 1 over y minus x squared equals to, I'm going to shift this one, become minus x log a plus b log a. So in this case, okay, by right, usually the x have to put it on the right hand side, but if I put the x on the right hand side, it looks very ugly. So I just leave it in this form. So for this case, my big Y is a very complex thing. So big Y is actually log 1 over y minus x squared. It's fine. Okay, it's fine. Okay, then my big X is just a single x. My gradient for this case, take note, it must be minus log a. Minus log a. My big C for this case is b log a. Okay, so this is for this question. Okay, then let's talk about G. G is y equals to hx squared over x plus k. Sometimes one look, you say, how to change to linear form? So what can we do? Sometimes just try out first. The only thing I can do now is I'm going to put y over 1 and then I cross multiply first. So I will get y rainbow with x plus k equals to hx squared. Okay, and then after that we rainbow out first. So you get xy plus ky equals to hx squared. Then you take a look, see which one is more easier to change it into a constant. This one, ky, because by dividing y throughout, I can make it become k already, right? So I'm going to divide by y throughout. So in the end, I get x plus k equals to x squared over y. So shift a bit, I will get x squared over y. This one is my gradient. Change. So I will put it this way. X equals to x squared over y minus k. Remember, big Y not necessary to have y inside. My big Y can just have x. So for this question, my big Y is small x. My big X is x squared over y. My gradient is h and my c is minus k. Okay, so this question demonstrates that your big Y not necessary to have y inside. Okay? This h. Because, do you see that there are 4 terms there? Most of the time, you only see 3 terms, right? So this one got 4 terms. How are we going to do it? I write the question first. So, what I do is, I can see that there are 3 terms who have y. So the first thing I'm going to do is I divide by y first. I'm going to divide by y first. I will get k squared plus 1 over y equals to x cubed plus hx. Okay, then I see which 2 terms that don't have the constant. For this case, the constant over here is the k and the h. So these and these doesn't have the constant. So I'm going to combine them to make them into big Y. So it becomes 1 over y minus x cubed. Okay, wait. Okay, is equals to hx minus k squared. So actually I'm done. My big Y is 1 over y minus x cubed. My big X is small x. My gradient is h and my c is minus k squared. Okay, so I'm done with the changing all this. Okay, let's move on to questions that are typical that come out, typically come out during exam. Okay, this is the typical kind of the short questions that will come out during the exam. Okay, so how do you know that this is linked to linear law? Very easy. You can see the axis. It's not the usual small y and the small x. Then you will know that this is linked to linear law. Okay, so the first thing, what do we do? You see, they say express small y in terms of small x. But currently, this is the so-called the linear law graph. So what do you do? So the first thing is, you think it like a coordinate geometry. When you're trying to find the equation of a straight line, it's always in the form of y equals to mx plus c, right? Then you always find the gradient first. After that, you will find the c. So it's the same concept. The only thing I request you to do is you're supposed to put big Y and big X. So the first thing is I'm going to write big Y equals to mx plus c. So as per normal, find the gradient. So in this case, my gradient I can find Y because I have 2 points which is on the line. So this is 6 minus 0 over 3 minus 1. So I get 6 divided by 3, I get 2. Then my partial equation now become Y equals to 2x plus c. Then I want to find c, right? So check the graph. Do I have the intercept? I don't have. So in this case, I have to sub either 3, 6 or 1, 0 to find my c. So let's say I sub 3 and 6. So it means this is y. So that means 6 is equals to 2, 3 plus c. Okay. And in the end, my c is equals to, did I sub something wrong? Wait, Okay, my math's too powerful. 3 minus 1 is 2, not 3. Quick. So this will be 6 divided by 2. So my gradient should be 3. So over here, this one is 3. This one is 3. Okay, so now my c is equals to 6 minus 9, which is c is equals to minus 3. So now I know my full equation is y equals to 3x minus 3. Then you say, oh, okay, now we are done with the so-called equation of the line. Then now you can replace the big Y to their actual small y, the big X to the small x by looking at the axis. So my big Y now replaced with 1 over y, and then 3x, 1 over x squared, and then after that minus 3. So we are done. But I want small y as subject. Now currently it's not exactly y yet. So what do you do is, I'm going to combine the right-hand side into a single fraction first. So it's 3 over x squared minus 3 over 1. So 1 over y equals to 3 minus 3x squared over x squared. Now cross multiply. Y 3 minus 3x squared over is bracket equals to x squared. Now I'm going to make y a subject. So y equals to x squared over 3 minus 3x squared. Done. So my small y is on the left-hand side and it's 1y, and my right-hand side doesn't have any y. So I already fulfill their requirement by saying y in terms of x. So, okay, don't underestimate the writing big Y and big X. Students always, very early, they already straight away go and convert into the 1 over y and 1 over x squared. It's very confusing, and the chance of mistake is very high. So I always make students write big Y and big X. Do it just like a normal equation of a line. After you settle the equation of the line, then you replace back to the small y and small x. Then after that, you just manipulate as per normal and make small y the subject. It's a lot more easier in this way. Okay, so then after that, part 2, they say, okay, find the value of y when x equals to 1.2. Part 2 is easy because you already have this one. So I just need to sub in x equals to 1.2. So my small y equals to 1.2 square over 3 minus 3, 1.2 square. Then in the end, my y equals to minus 12 over 11. Okay, for me is I always like to give my answer in mixed number. Put on both also can. So it's minus 1 over 11. Okay, so this is for question 3. So this is similar to like question 3. Okay, the only difference is, of course, this one is in logarithm. So I just do it for you. Okay, let's see. They say the diagram shows a straight line. Okay, log y against log x. Okay, acknowledge. They say express log y in terms of log x. So same thing. We're going to write big Y equals to mx plus c. So let's find the gradient first. So find gradient will be 2 minus 0 over 0 minus minus 4. So I have 2 over 4, which is half. So my equation of the line now become y equals to half x plus c. So this one I don't need to sub in. Why? Because actually, do you see that I have the y-intercept? My y-intercept is 2. Okay. So straight away I say, oh, so y is equals to half x plus 2. Okay, then after that I'll say, okay, now I can start to replace my big Y and big X to all the small y and small x. So this one become log y equals to half log x plus 2. Check, yes, correct. Then they say they want log y the subject, right? Now take a look. It's already log y the subject. And yep, ta-dang, that's the answer. Okay, next is they want small y to be the subject. This is for part A. Now the question is this, how am I going to make small y the subject? Okay, log y equals to, so I will have to combine my right-hand side to a single logarithm. So how I'm going to combine is, this half, I must bring it up. So actually it become x to the power of half, agree? And to the power of half is square root. So this become log square root x plus, and this 2, I want to change it to logarithm. So log 10 is 1 whole, right? So I'm going to put a 2 in front. It becomes 2 times 1, which is 2. Then after that, power law, I'm going to bring this up. So it becomes this. Okay? Then now I'm ready to combine this into a single logarithm. So log y equals to log square root x multiplied by 10 to the power of 2, which is 100. Okay? Now both sides single logarithm, I can remove the log. Okay, say, oh, so y is equals to 100 square root x. And that is my answer. Okay? So we are done with this question 4. So question 3 and question 4, they draw the diagram for you. So question 5 is similar to them. It's the only difference is they never draw out for you. But it's okay, you just convert and then you just plot accordingly. So variable x and y are related by the equation, okay? They give me the non-linear form. Then they say that when a graph of y is plotted against blah, blah, blah. So they already tell you what's the big Y and big X, right? So what you can do is you can just write to just remind yourself. So big Y is small y. My big X is 1 over x cubed. Then they tell you that the gradient is minus 2/3 and the y-intercept is obtained. This is negative or what? Okay, this means that the y-intercept negative 7/4 is obtained. Okay, so they're trying to tell me gradient is minus 2/3. My big C is equals to negative 7/4. So when we write out the equation, it is actually equals to y equals to minus 2/3 x minus 7/4. Okay, then after that, what I'm going to do is I'm going to replace it with this one. So my big Y is small y minus 2/3. My big X will be 1 over x cubed and then minus 7/4. Okay, then your task is you are supposed to find out what is A and B. Do you see this is the original non-linear form? So now your task is to massage this to become this way. Okay, so let's see. Okay, now it is important that from here, let's shift it to the linear form, which is like what we learned in question 1 and question 2. Ax cubed minus 2 equals to bx cubed y. And over here, you know that small y is the subject. So let's shift it. I'm going to do bx cubed y equals to ax cubed minus 2. I'm going to divide by bx cubed throughout. Divide by bx cubed throughout. So I get y. This one you can write it out first. This one becomes this. And you can see that the x cubed can cancel. So it becomes y equals to a over b minus 2 over b 1 over x cubed. Shift it a bit. So y equals to minus 2 over b 1 over x cubed plus a over b. Aha. So now you can compare. You notice that my gradient is this and over here is this. So minus 2/3. Use another color. Okay, minus 2/3 is equals to minus 2 over b. So actually this one no need to solve, very straightforward. Straight away I know my b is equals to 3. Then now you know this is equals to a over b. So my a over b is equals to minus 7/4. And because you already solved your b, so put it in. So a over 3 is equals to minus 7/4. Now cross multiply. So my 4a equals to negative 21. So my a is minus 21/4. So therefore, a equals to minus 21/4 and my b is equals to 3. Done. Okay, so what we did is, this question is, they give me the gradient. We write out the equation of the line in terms of big Y and big X first. And then after that, we replace it with this small y and small x. And because they give me the non-linear form, then I massage to become the linear form. And then we start to compare. And we can start to solve the A and B. Okay, so I'm going to minimize. Oh, too small. Okay, now you all take photo and then you all can zoom. So this is the graph question. Okay, this is of course my front of the front of the graph paper, and this one is behind. So let's read the question. So they say the following table gives the blah blah blah, and usually they will always give us a non-linear form with all the a and b or the whatever constant which is unknown. Okay, then they always give us x and y. Quite best standard one. Next, sometimes they give you scale, sometimes they don't ever give you scale. They never give you scale, you got to decide yourself. You have to plan properly. So over here, this question, they did tell you, I want my big Y to be small y, my big X to be 1 over X. That means for this situation, you cannot decide yourself. Then the next thing is, remember I say that we need to always massage the non-linear form to the linear form to decide what is my gradient and my big C. So look over here, this is the one that they ask us, this is the non-linear form they give me. So always behind the graph paper, you write that one first. Then as per like question 1 and question 2, you're supposed to massage. So I massage. In the end, I get this one. So this is very crucial. But again, this question 6 is still only considered 1 mark. Why? Because the gradient is just A, the big C is just B, very straightforward. Then after that, how are you going to plot the graph? Okay, see, my big X is 1 over X, my big Y is Y. So you can see, I'm going to maximize a bit, that at the top right-hand side here, I put in the big X and the big Y. Okay, and 1 over X is my big X mark, and then my big Y is small y. Then after that, I will base on this table. Okay, of course, my Y is just follow this one, nothing much. My big X is 1 over X, so I need to do 1 over 0.5, which is what? 1 over 0.6 is what? So actually, every time, sometimes the answer is not final terminating decimal, then you will just round off to 2 decimal place. Okay, 2 decimal place is good enough. Okay, so now I have my points. Next is I'm going to plot. Okay, make sure you all always plan the graph before you all draw up. Because sometimes a lot of students plot already. Wow, then I tell you, not enough to cut. Because you must understand when you draw linear log graph, you must make sure that you have your big y-intercept. So sometimes they plot already. And in order to get the big y-intercept, you need to extend the line. But you're not able to extend. Why? Because your scale not enough. You understand? So you need to plan first before you draw. You don't after that you plot, and then after you say, oh shit, I cannot do the y-intercept. Then you got to redraw the whole thing. You understand? Okay. So this one I plot straight line. Okay. Just take note that sometimes the line is not, the points will not exactly join exactly the same. So it's always drawing best fit line. What is best fit line? Best fit line means that your line will lie very close to most of the point. Okay, and sometimes take note if let's say you see that all the points when you draw got one extra point very up, you understand? Then you will have to read the question and see, because sometimes the question will ask find out what is the incorrect value point. Then you know that one is the out one. Okay, but if your question never mentioned about incorrect value, then you got to check whether your table of points is wrong or not. Okay, because the line is supposed to be best fit, it's very close to the point, but there will not be one which is like out. Like for example, if let's say you draw this one, then suddenly this one pop out, right? And then you notice that this question never asks for incorrect value. Then you will have to go and check your table, see whether is it you plot wrongly. Okay, so for this case, this will be the straight line. Okay, then after that, they want us to find what? They ask to find A and B. And from here, you will know that the A and B simply means to find the gradient and the y-intercept. And then take note, very important is to find the gradient, never take the points from here. So a lot of students always say, oh, gradient, I take y1, big Y minus the this one Y, then after that X over minus this one X. Okay, you are not allowed to use the point from the table. Why? Because remember, we draw the line is best fit line. So it means that the points not necessarily is your line. You understand? It's on the line. So it's only estimation. So you will have to take points from your graph. So for this case, you can see that I put a point here and I write up the points. And this one also. Okay, you can find any points on the line. Okay. So then after that, what I do is I always write like that. From the graph, my gradient for this case is A. So I write out the 2 points. Then I apply the formula. Gradient equals to blah, blah, blah. So it's 8. So I know that, then after the next thing is, we know that the y-intercept for this case is P. So from the graph, you can see that the big y-intercept is 2. So over here, 2. So in other words, B is 2. So in the end, A is 8 and B equals to 2. So this is how you do this kind of linear law question. And how are you going to label the graph? Put small y here because my big Y is small y. Then over here, I put 1 over x. Right? And a lot of students say, hey, how to label the line? So you see, because I already have this one over here, so what I did was I labeled this one here. Okay? If you want to label this over here, you are also not wrong. Up to you. Okay, so this is for question 6. Okay. Okay, so same thing, they give us a table of points, which is x and y. Again, they tell us what is, they say ln y against x. Okay, so same thing, I'm going to write my small x because that's my big x, and big Y is ln y. Okay, make sure you always arrange it in x and y, because sometimes my students, remember, sometimes the big Y can be just x, remember? Okay, then after that, students accidentally will put the so-called, although the big Y is x, they go and put this, okay, at the top row. Then it's wrong with you, because it's supposed to be big Y. So if it's big Y, it's supposed to be at the second row. You understand? Okay, so I'll always write this out so that I will remember to put them in terms of big X and big Y. Then I will plot the points correctly because you always read X, then read Y, Okay, so now let's take a look at this question. Okay, after I plot, okay, ln Y against X, and then I plot the point, it forms a straight line. Then same thing, okay, I find my gradient. Okay, I got this one, and then I find my this one, I get 3.2. Next is I'm going to write out big Y equals to my gradient, big X plus big C. Then after that, you're supposed to make Y a subject. This one I don't need to teach you already. Okay, then the next thing is this part. They say find the value of Y when square root X equals to 1.8. There are a lot of students was jammed. Why square root X? They don't know what to find. So the trick is you always look at what is your big X and big Y. So for this case, your big X is x1. So square root X, see here, when square root X equals to 1.8, I want to find out what is my X because this is what's my constant. So I square both sides, I get 1.8 squared, you get 3.24. It means that you got to go to your graph, go and find 3.24, then dot, 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 dot. Make sure you draw the dotted line because you're supposed to take the value from the graph. So you draw dot, 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 so you see it's 1.6. And then take note that don't go and say that your answer is 1.6. Common mistake, students say, oh, my Y is 1.6, and then full stop. But you must take note that this is not Y, this is ln Y. So you have to make sure you write, oh, so when X equals to 3.24, ln Y is 1.6. So you still need to massage to make Y the subject. Okay, so this is ln Y equals to 1.6. So what I did was, this one is base E. So you always reveal the base, change to index form, push up. So Y is equals to E to the power of 1.6. Press calculator, my Y is equals to this one. Okay, so take note, don't straight away say your Y is 1.6. You have to see what is your big Y. Okay, that's a common mistake. So of course, after I teach, you don't have all this kind of common mistake. So this is for question 7. Okay, this one question 8. Okay, again, they give us the non-linear form. So you see behind my graph paper, I will massage. This is based on like question 1, question 2, the skill they have learned, right? And then you must always write out this one. Next is, they always ask you to find the unknown alphabet one. For this case, my gradient is K, my big C is log H. So again, from graph, so you see, do you notice that my table now I draw on the left-hand side instead of the right-hand side? So initially, when I was plotting this graph, I was looking at the points. Okay, then I will know that my line will actually go up. So I was afraid that if I move up, and then after that, I will get blocked. So I go and draw my table on the left-hand side. But in the end, the scale is enough, you see, so it doesn't matter for this case. But this is how you're supposed to plan before you draw. If not, later after you draw it, then you regret, oh, then I have to redraw everything. Okay, so I draw the table. And then after that, I draw the line. So I'm not going to talk about that. Then after that, again, from graph, you can see that I actually take the 2 points. So I take 2 points, one, write down there, another point, I write down there. Then after that, always, I very kiasu one. So I always write out the points here. Why? Because if you can flip, after that, my gradient, I use the wrong number to calculate. So I always write out the 2 points out here. Then I apply the y1 minus y2, x1 minus x2, then I will not go wrong. Okay? Always minimize the careless mistake that you can commit. Then after that, okay, my gradient is 1.5. And for this case, because my gradient is just k, so straight away my k is 1.5. Then over here, my big C is 0.375. Okay? Sometimes do you notice that actually when they are like so big, okay, then you don't know what is the value. Okay, I teach you one, that's my method. You see how many square are there? There are 10 and 20. So over here, there are 20 gaps. I call it 20 gaps. And this is 1. So I just take 1 divided by 20, I get 0.5. I think 0.5, 0.05. 1 divided by 20, 0.05. So I know one gap is 0.05. Then you see this one cut over here, we will know that it is 7.5 square. So I take this, multiply by 7.5 gaps, and I get this 0.375. You understand? So I will not go wrong because how are we going to calculate, right? So this is how I calculate. I find out one gap is how much, then I calculate how many square, I just multiply by the square, then I will know that I will not go wrong with my value. So I know my big y-intercept is 0.375. So come back to here. My big C is this one, but my H is, remember, see this come in handy now. So log H equals to 0.375. Then again, log is base 10, so push up H equals to 10 to the power of this. Press calculator, I get this. Always round off to 3SF. Unless the question asks you to round off to other stuff, by default, it's always 3SF. Okay, so then after that, we're done with the first part. Then let's see. They ask us to use your graph to find the approximate value of y when x equals to 18. Then when you look at your big X, is log X. So remember, we have to, when X equals to 18, I have to find out what is my log X, which is the big X, is 1.255. So I go to my graph, I go and find 1.255. Okay, this one, I round off to 1.26. Then after that, over, and then I found out that this is 2.275. And please be careful that this is log Y. So I will say, from graph, log Y is 2.275. I need to find the corresponding Y, and I get this. Okay, my answer here is 180 by its estimation, because everyone draw the straight line might be different, see? Different, but because we are drawing best fit line, so my best fit line and your best fit line might not be exactly the same. So it's only plus minus a bit. Okay, then you will think, the answer is 180, and then my Y is 188. How can it be the difference is so big? Because this is logarithm. Okay, a slight difference, after I so-called unlock it, it will become very big one. So it's fine. Okay, the most important is the concept and the method, and you will get, definitely the teacher will give you the full mark. So this is for question 8. All good? Any questions so far? Okay, I'm done with my graph. There is one last question 9. Question 9, I'm not going to draw it out, but I just going to mention about the few things to unstuck you so that you can do it yourself. Okay. So the first thing is, they say, wow, the year 1990, 1995, 2000, 2005. Then the P is blah, blah, blah. Then the student thinking, how can we draw this thing on the graph? Right? Don't worry, don't panic. Read the question first. Because they say the T is the time measured in years from the January 1985. So you're not complete yet. So you're supposed to plot one more called T. T is taking the year minus 1985. So 1990 minus 1985 is 5. 1995 minus this one is 10. 15. I'm going to guess it's 20. Is it? Yes, 20. So it's in the end, my T is 5, 10, 15, and 20. So the year is actually redundant. You're not going to draw it on the graph. You're supposed to do P and T. So over here, this is P equals to 10 plus ATN. So this is the non-linear form. Remember, when we have a power whereby it's alphabet, you're supposed to log on both sides. But when you see a plus, you cannot immediately log on both sides. You're supposed to bring one of the term to the other side first. So it becomes P minus 10 equals to ATM. Then yes, you can log on both sides. Now, in this question, they never state big Y, big X, so you decide yourself. So let's say I'm going to log both sides. Okay, so say I log both sides. I will have log P minus 10 equals to log ATN. Split it. So I have log P minus 10 equals to log A plus log TN. So shift a bit. So my log P minus 10 is equals to N log T plus log A. Big Y for this case is a super complex, this one. Then my big X is equals to log T. My M is equals to N. My C is equals to log A. Okay, after you know such, then for this case, you know that, oh, behind I'm supposed to draw, the graph, you're supposed to draw log T minus 10, and then my big X is log T. So when you draw on the graph paper, make sure this one, first one is log T. The second one is log T minus 10. Okay, based on this P and T that you have over here. Then again, you have the points, then you plot. I don't know what the line looks like. So this is how you're supposed to get. I'm not going to do the remaining question, the graph for this one. I just want to highlight that you're supposed to have T, and it's from taking the year minus 1985 to get the T. And then after that, I want to also show you that you cannot straight away log along both sides because of the plus. You need to split it, and not split. You need to bring the one of the term to the other side first. For this case, it's P minus 10. Then yes, you can log along both sides now. Okay, so this is the final question for tonight.